Hello, this is John from caveofprogramming.com. In this video we're going to take a look at lambda expressions in Kotlin. Lambda expressions are basically an alternative to anonymous functions. They have a syntax that could be considered more elegant and shorter for many purposes. Let's create a variable here of a function type. I'll call it greeting. We'll say that this variable can refer to a function that accepts two parameters of type string, and whatever function it refers to also returns a string. So if I want to set this equal to something, we could use an anonymous function as we've seen, but we could also use a lambda expression. Lambda expressions go in curly brackets and we list the parameters separated by commas. Let's have name1 and name2. Then we have an arrow, and then we have the body of the lambda expression, which can consist of multiple statements. But the last line should be an expression, which is going to be the return value of the lambda. Remember, an expression is just something that boils down to a single value. So for example, we could have, of course, here a string. And let's say hello, $name1 and $name2. So now that variable is pointing at a valid function. It might not look like one, but it actually is one. Let's print out the return value of greeting, and I'm going to call it with two names like Bob and Sue. So if I run that, you can see that my lambda expression here has actually returned a string value, which we're now printing. So in this case, Kotlin can infer the types of these parameters from the type of the variable that I'm making refer to the lambda. You can explicitly specify the types of the lambda parameters if you want to. With a lambda, there's no way to specify the return type. That's got to be inferred from the last expression or from the type of the thing that refers to it. If you need to be able to specify the return type of an anonymous function, then you need an actual anonymous function with the fun keyword. Lambda expressions are particularly convenient for the situation where you want to pass a function as an argument to a function. So let's create a function here called showOp, and I'm going to say that the first parameter of this function is going to be called op, and it's going to refer to a function that accepts two ints as parameters and returns an int. And then we'll have x of type int and y of type int as parameters to showOp. ShowOp is going to just do a print line on the return value of whatever op refers to, passing in x and y. So now let's see how we could run this function. I'm going to write showOp, and we need to pass a reference to a function for the first parameter. So I could do that with a lambda expression. Let's have curly brackets in here, and that's got to accept two parameters. So I just write those separated by commas. And then we have an arrow, and then we have an expression that becomes the return value. Let's just put x plus y. Now we have to specify the two other parameters to show up here, x and y. So I'm going to put 6 and 5 maybe. And if I run this, you can see that showUp prints 11. So it has successfully run this lambda expression, which is basically just a function. And this is really the main use of lambda expressions, just to pass functions to functions. You can perfectly well have a lambda expression that has no parameters. Let's have a val, I'll just call it result, and let's say that this can refer to a function that has no parameters and has a return type of int. I can set that equal to a lambda expression, and I just need some expression in here that's going to be the return type of the lambda. So if I do print line result, that's actually referring to a function, and I run that, then I get 5 down here. Of course, that's a really useless example, but you can have multiple lines of code in a lambda. So let's create a bit more space here, and here I could have, for example, print line running lambda. I don't know, these are silly examples, but what I want to do is just show you the basic syntax of lambda expressions. So let's run this, and you can see it works fine. So running lambda is coming out down here on the console, and the last expression, whatever it should be, even if it's just a number or a string or something, becomes the return value of this lambda expression. I'm going to run the auto formatter here from the code menu except I'll use the shortcut. It did make some minor changes there. So one last example that I want to show you is the case where we have a lambda that has a single parameter. Let's create a variable called condition, and let's say that that refers to a function that can accept, let's have a float for a change. It can accept a float and it returns Boolean. And we want to implement this with a lambda expression. So as always, we have the curly brackets. And in this case, we could write something like x, that's going to be the parameter, arrow, and I could return, for example, x is greater than 10. And that's perfectly valid. Let's do print line condition and let's supply it with 11. So we should expect to see true being printed out here. Oh yeah, except I used a float. So I actually need something more like, let's put 11.1, and I need f to say that that's a float. So if I run that, it works and we've got true down there. However, if the lambda has only one parameter, we can actually just miss it out. And if we need to refer to it within the body of the lambda, we can use it. That will refer to my one and only parameter. So when I run this, we get true coming out again on the console, so it works just fine. If I change this to something that's less than 10 or even equal to 10, then we're going to get false. There's false. So the fact that you can write a really short expression like this for a lambda if it only takes one parameter means lambdas are great if you want to do a more functional programming style. If you want to filter a list and you just want to create a function that specifies how it should be filtered, something like this, then you can do it with very little code. So that's it for this video. Until next time, happy coding.